Dr. T's Research Methods Basics Hypothesis Testing Part 5. We are going to go over some definitions and a few examples regarding determining what type of test you're doing, regarding where that p-value should sit under a normal curve. So this is important now that we have the different types of test statistics we will be using in our hypothesis test. We need to know, well, where is this p-value? Where does it lie? How do we know if it's actually a significant finding in our test or not? So I'll give you a few kind of pointers as I define these things. So a left-tailed test essentially is saying this, that our test statistic is here, or should be somewhere here. So there's our test statistic. And we are interested most in the values that are most uncommon, right? We're not likely to just grab them out of the general population. They're pretty significant, pretty rare. If our alternative hypothesis has the words or the symbol for less than, we are doing a left-tailed test. This is important when we're going to find this test statistic and when we're trying to take a look at our p-values. Okay? If our test statistic is over here, then we are most interested in the values that fall somewhere in here. P-values are in there. And if our alternative hypothesis has the words or the symbol greater than, well, then we are doing a right-tailed test. And finally, if our alternative hypothesis has the word equal or the symbol equals, then we have a positive and a negative test statistic. Let's see if we can kind of say why here. Remember, here's our population mean, and these were our standard deviations. So you would have one standard deviation above the mean, two standard deviations above the mean. You would also have, on the other side of the mean, one standard deviation below, another standard deviation, two standard deviations below. So if our alternative hypothesis contains the equal sign, then the p-values are kind of on both ends of the curve here, and p is twice the area to the left of the negative test statistic and it is twice the area to the right of the positive test statistic. So that's a two-tailed test. All right, let's work through a few kind of examples, and we'll practice just a little bit here. Okay, so let's say a university claims that 82% of its students graduate in 4 years. All right, well, our null hypothesis then, remember the null hypothesis always has the equality, is that the proportion, that's that 82%, the proportion of students is 82. Our alternative hypothesis is that the proportion is something else. It's not equal to 0.82. All right, so what kind of test are we going to do? Okay. Well, we have an equals sign, even though it's a not equals, in our alternative hypothesis. So that means we are going to do a two-tailed test, and we are interested in values that fall in the right positive tail and the p-values that fall in the left negative tail. That wasn't terrible. Let's try another one. Consider this claim. On average, a district attorney's office handles at least 20 cases more per day this month than they did last month. All right, well, let's go ahead and figure out our hypotheses. So our null hypothesis then, it's going to be the one that has an equality, right? So our null hypothesis, and they're talking, at least 20 cases more per day. That's an average, right? So we'll say that it's, mu is less than or equal to 20 cases. And our alternative hypothesis then is that mu is greater than 20 cases. Cool. All right, well, we have in our alternative hypothesis here a greater than, which is telling us that we are interested in the p-values here in the right tail, and we're doing a right-tailed test. Okay, so all of this talking about p-values and tail tests and hypotheses, let's kind of dial it all in. How do we use the p-value? Well, if our p-value is less than alpha, we can reject the null hypothesis. If our p-value is greater than alpha, then we fail to reject the null hypothesis. Now, I've gone ahead and given you a little bit of a decision cheat table here. Kind of helps me when I'm doing actual hypothesis testing to take a look at a table like this. Helps me figure out how to word things. So if the claim that is being made is actually the null hypothesis, if the claim that is being made actually has the equality in it, and I know that the p-value is less than alpha, I'm going to reject the null hypothesis, and I can say there is enough evidence to reject this claim. See how this table works? Let's try another one. I run a test. The equality in the hypothesis that I'm interested in is actually the alternative hypothesis. And my p-value is greater than alpha. I'm going to fail to reject the null hypothesis. And I'm going to say there is not enough evidence to support the claim. Remember, even if we have a p-value that falls way out into the tail of a distribution, it's highly statistically significant. We still can't say we've proven anything. That's why this kind of decision cheat table can be helpful. It keeps us from being too definitive. Why? Human. Human is why. It only takes one scenario, one outlier to flip everything we think we know on its head. So after all of the calculations that we've been doing, here are the steps for hypothesis testing. First, you need to state the claim and write out your null hypothesis and alternative hypothesis. Often when I do this, I will do it exactly like this. I'll write out whatever is what I'm going to be testing. And I'll also note which one is the claim, just for my own reference. Specify alpha. Specify the level of significance. It's going to be 0.10, rarely, but can be, 0.05 or 0.01. I'm going to determine the sampling distribution and sketch the graph. Most often in criminology, criminal justice, we're using a normal distribution. So you can go ahead and sketch that. You're going to calculate the test statistic and standardized value. So we need to know, are we looking at a z, a t, chi-square? I will then go ahead and kind of sketch the type of test I'm doing. It's going to be right-tailed, left-tailed, two-tailed. I'm going to find the p-value, and then finally I'm going to make my decision. So here's kind of a bit of a chart to use. It's a decision chart. If p-value is less than or equal to alpha, then I can reject the null hypothesis. If the p-value is less than or equal to alpha, and I say no it's not, then I'm going to fail to reject the null hypothesis.